Hello grade 9s and welcome to probability. Now, first question, I don't want you to Google this or ask your mates just yet, but what do you think probability is? I'm interested to read what you've written. I don't know if you would have talked about it's the chance of something happening or events and outcomes, or who knows what you would have talked about, but in its basic sense, what's the chance of something happening? What's the probability? So we're going to run through 3 different examples so that everything's in this video that you need to do. So the first one is, here I've got a 5 rand and 5 rand coin, and it's got heads and it's got tails. And yes, the side on that side is generally heads, even if there's a head on that side, because coins used to have, like this British £1 has a head on it. Let's see, this has got something else. Anyway, so the question is, what's the probability that when I toss this coin, it's going to be a head? Okay, hopefully you've given some sort of idea. Now, the probability that it's going to be a head is a half. And let's explore, why is it a half? Well, why do you think? Just describe in words, why do you think the probability that when I flick this coin, it's 1/2 that I would get a head? Okay, interested again to read what you said. I think one of the ways of looking at it is to say, well, there's one head and there are 2 possible, and let's introduce this word, outcomes. So there are 2 outcomes that we've got here. The one outcome is heads and the other outcome is tails. So therefore, out of the 2 outcomes, one is heads, so therefore the probability is a half. Okay, round 2. What's the probability that I get a head when I flick the coin now? Still a half. Each time I toss the coin, there's one head and there are 2 possible outcomes, heads or tails. So therefore, it's a half. If I toss this 100 times, the next 101st time when I'm going to toss it, still 1/2 that it will be a head, or 1/2 that it's going to be a tail. So sometimes it's called the gambler's fallacy, that you walk into gambling place or you walk somewhere and it's been 100 heads and the person says, so do you want to put some money on this being a head or a tail? Probability, unless if it's a fair coin, the probability should be 1/2. So when I say it's not a fair coin, what do you think the difference between theoretical probability, so that's just the theory like I've written down there, or experimental, doing it by experiment, is? So what do you think the difference between theoretical probability and experimental probability is? Okay, again, I hope that you're just asking, and these are new terms that we're coming across. So the one we talked about is theoretical, and the other one is experimental. So theoretical is by theory. By theory, there's one head and there are 2 outcomes. Experimental, we're not going to do in this video, but I could toss it, or you could toss it, and we toss it 10 times, and we see how many times it comes up one or the other. And we're going to come back to that. Okay, so that's our coin scenario, quite a common one. What about, let's take a die. So again, one die, many dice. So we've got one die here, and I'm going to roll the die and see what's the probability that I get a 3. So what's the probability that when I roll this die, I get a 3? Well, I'm going to roll it. Well, I'm going to roll it just by putting it up in the air and putting it down. My goodness, really, I got a 3. So the probability of getting a 3, let's do it according to this idea, is, and you can see what's coming up, is that we've got, let's go this color. We've got 6 options on the die. We've got 6 faces, and of them, one of them is the number 3. So the probability that I rolled it and got I'm serious, I've got a 3 again. The probability that I got a 3 is 1 in 6. Okay, let's run through another example with a die. Okay, I'm going to pick another one just for the sake of it. Looks like I'm about to do a magic trick here. What's the probability that when I roll this die, or toss it up and randomly choose it, it's a fair die, it's not weighted. What's the probability that I get an even number? Okay, so I'm going to do it. Let's see, randomly, let's see what we get. What number do you think is going to be on top now? That one eventually. You won't believe it. Look at it. I'm going to do it like this. It's a 3. This is insane. Okay, but anyway, the probability, we're asking ourselves, that it was going to be an even number. How many options are there? Well, there's 6. How many of those are even numbers? 3 of them. Now, whenever we deal with probability, we always put it in its simplest form. So 3 over 6 you must write as a half. Let's run through the die just a little bit more and say, I think I should have space to put it up here. What's the probability that when I roll this die or throw it and catch it, that I get a 0? Now this is a normal die. It's got 1, 2, 3, 4, 5, and 6. What's the probability that when I roll it, I get a 0? Well, let's do it this way. We've got 6 different options. How many of them are zeros? None of them. So we've got a 0 and 6. It's 0. It's never going to happen. What's the probability that when I roll this die, I get a number that is bigger than 0? So I roll it. What's the probability that it's bigger than 0? Well, let's look at it like this and say, well, we've got 6 options. And of those 6 options, how many of them are bigger than 0? 1, 2, 3, 4, 5. They all are. So 6 out of 6. So it's always going to happen. It's a certainty. So 0 probability, never going to happen. Probability of 1, we can say, is a certainty. Okay, so all of these new terms that we're throwing in. Our last example that we're going to do for today. I've got some cards here. And from these cards, I'm going to take them out. These have been used before. I'm going to shuffle the cards. And what's the probability that when you select a card, what's the probability that I get a heart? Okay, now, not everyone plays or grew up with card playing, but cards are so useful in probability. It's one of those things that we need to learn because it's so useful in probability. So what I've put here is, they're all the cards that we've got. We've got everything down from an ace. So we've got the ace of clubs, and it works our way all the way up until we get to a 10. Now somewhere over here, I should surely have a 10. There we go. There's a 10. And then instead of having 11, 12, 13, they jack, queen, king. So as I said, maybe you grew up with cards and you knew cards, or you play cards all the time. Great stuff. As a matter of interest, how comfortable or confident are you in knowing all the different cards? Just please give me an indication of, yes, I know the whole pack, or actually I've never played cards before, or I've got a bit of a sense of them, but I don't know what things like face cards are, or court cards, or is ace the lowest or the highest. So please, just some sort of indication, because as I said, they come up quite often. Okay, so in our cards, these cards over here are called face cards. And I know my face is covering up some of them, but these are face because look, you can see their faces on them. We've got 4 different suits. We've got these ones here are the clubs. These are the diamonds. These are the hearts. And finally, we've got the spades. Okay, so if I asked you what's the probability of drawing a heart, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 hearts. So we'd say there are 13 hearts. How many cards are there altogether? Well, there are 13 in a suit and there are 4 suits. So each of these is a suit. So there are 52, which is 1 over 4. Or you can just see, hey, look, there's 1 heart for every, there are 3 other suits, so 1 in every 4. You could have gone straight to your simplest answer. So cards are something that we're going to get familiar with during this time. So what's the probability of drawing a jack? Okay, well, how many jacks are there? 1, 2, 3, 4. So there are 4 jacks. How many cards are there altogether? 52. So 1 in 13. Notice that mostly when we deal with probabilities, we generally do not deal with cards that have jokers in. We say it's a standard pack of 52 cards. So there we go. That's it. What do you think of this? What do you think of the new video, or slightly new video style? Okay. Thank you. Okay, enough.